Hi, Binary Viking here, and I'm back with another tutorial on C#. So, first off, I'm back in the person class, as we can see here, and I want to extend this one further. So, first of all, I thought about what I said last with the BMI example. So, what we want is a possibly private int. Actually, we don't want int. Where I think about, we want uint, because usually a person would never have a weight. I think I typed that one wrong, but never mind. But a weight would never for a person be negative. If it was something that could be negative, we could just do int. And we also never want the person to, or that would never, possibly never be a person that had a weight over 2 billion something. So we could actually just go with a U short, which is only a 16-bit. And I think this one goes up to, I think it's something about 50, oh sorry, not 56, 65,000. And you may now ask, that's a lot too. And yes, it actually is. And the reason why I'm using ushort instead is because the next one is a byte, which only goes to 255 if I'm correct. But you can use whatever you want, you can even use it, but remember, if you were to make a big system that you want to really have some sort of extra safety level on, you do really need to use the types correctly. But for the sake of it, I think I just roll with int for now. But remember, you probably would want to use uint or ushort or something similar to that if you were to make a system that should be used in the real world. And I now copy it and I will set in height. I don't care, I probably wrote everything wrong. So now where we have that, we can go into our constructor, and we want the constructor here to add, wait, and actually I will fast change it to a big W and a big H, as we want this lowercase down here instead. It's pretty much just the way I do it, although may do it differently, but this is the way I program, and there's different way of programming or setting up the variables to quote unquote look good or look readable. But this is the way I usually do it. I sometimes put underscore in front of them like this, but this. But for the sake of it, I will not do it, as this is actually the best way or the most normal way of doing it. So we will down here add weight equal weight with small letters, and height with the big H equal height with the small h. And still, I think I typed it wrong. I am not, oh, small h. But I don't care too much about typing right now. So next thing is, we want to be able to calculate the BMI of this person. So what we want to do down here is to add a public string method. We can call it calculate calculate BMI. That would be what we would normally do, but in this episode I do want to show a new thing we can do, which is called properties. So instead of this, we will make a property up here, and this property will be a get only. You would usually be able to both get and set properties, and I will show that too in an upcoming tutorial. So we can say public int, of course. Actually no, we need to be float, or even we can do double actually, sorry. So double is a floating point number, and what that means is the floating point number is, as it says, something that have a comma in it. So it would be something like this, for instance. That would be a double number, or a valid double number. And here we have BMI, and now we make a body. And this may seem weird, but we again here have a get. And this is where it may seem a bit weird for if you haven't ever used this before. But it actually is defined kind of like a method here. So we have a get, which should or must return a double. So in here, say return. Now I need my big math skill. It's weight. I can't even remember how to calculate BMI. Is it? I do think it's weight divided by. Now we need a new thing called math, and that's the power of height. And I do think we do height in centimeters, and because of that we will divide by 100 to get meters, and double y, and that will be 2. So pow here is power, so it's height divided by 100 to the power of 2, so it's height times height pretty much. So if I do this, we should see that it works out. Oh yeah, right, we fixed that one in a bit. So it will now take weight divided by the power of height divided by 100, and that's the power of 2, of course. So we here have the number, and we here have the power. So what we will do in here is to add the weight, and I do not really know what that should be in, but I guess kilogram is what you usually do. So we can say 60, and we can say height in centimeters 180, and we can save it, and we can then go ahead and compile it. Oh, sorry, actually we also do need in here to add plus person, sorry, dot BMI. And we can see here that BMI shows up differently as the others, and this symbol here represents that it's a property. So if we do like this, we should see binary 60, sorry. And I do think my math skills is a bit wrong. I sadly can't remember how you're supposed to calculate BMI. You can fast look it up actually. BMI. Oh, not maps. God, stop that. So BMI is some Danish things here, and we have the okay, so it's pretty much as it was in here, with weight divided by height, as it is here in meters, to the power of 2. So I'm actually a bit confused why it's not working out. I do actually think it's maybe because that we need to define these as double as well. The reason being is that it sometimes does not work correctly if you divide it by any number. It will simply be 1, or it will at least not be a floating point number. Let's just keep to that. So if I compare it now, we actually have the correct value here. 18.51, so on. If I change, let's say, the weight here to 100, we should see the BMI also changing to actually be way too much right now. Well, it's the correct value, but it's a person that maybe should consider losing a few kilos. So that's kinda it. We can also say we want to set the BMI, but in this case we can't exactly do it, because we can't set the BMI since BMI is defined by 2 other values. But we could, for instance, say we want to be able to get or set this name up here. So instead of having private, we want it to be public string, and we want to be first name get. So in this case we do not want a body because we do not want it to return anything. And the reason being is when you write it like this, it's just returning first name as a string. And we can then say private set to say that we can only set the name within this class. So what we can see now is if we go in here and say person dot first name, we can actually see it right here. We can get the name, but if I try to do something like this, any string, we can now see it's inaccessible because it's a private set. But we can easily get it, and we can even, I can even show this by doing, instead of this, we can go down here and just set it like this, and it should compile. We have Viking, yes, and everything works out as planned because we can get it, but we can't change it or set it. So this is a read-only property, it's also called, or it's read-only outside the class. We can of course change it inside the class because private is changeable inside the class. We can't do the same for last name. We can do like this. And we could do the same for anything else down below here, but I want to at the moment keep it simple. And you may now ask, but how does all this work? Because we see here that it returns other values as a method. How can this actually store a value? And that's a valid point, and the way it actually works is behind all the code it actually writes this out: string underscore first name. It actually adds this to the code without we seeing it. So the compiler itself will add this to the code when this is in here. And writing this right here is actually equal or the same as writing Bear with me a moment. It's exactly the same as writing like underscore first name and first name equal values like this. So this down here is actually exactly the same as I wrote up here, except it's of course two different names. So if I changed or removed this, it would be the exact same. But for instance, we can say up here we want when the value is set, or even we get the value. Normally, well, not normally, but most time you will maybe do something with the name or anything. When it's set, the value is changed at least. We can for instance say we want the value dot, not there, sorry. We want down here to say value dot substring. And again, we can take like this. And what we should see now is that the first name is now changed, as we saw in one of the first examples about, yes, exactly here. As we saw about the values and types, I had some tutorials long ago, or some ago. So that's kinda it, to be honest. There is of course other, we can say get full name like this. Oops, of course we need to add in the parentheses because it's a method. So now every time the value is set, it will remove the first letter and then take any 3 letters after the first letter and actually set that to the first name. And that's why we can see it's now IKEA binary. We could for instance also change down here. We can for instance make a property for weight where we can say the value must never be higher than something or may never be smaller than something. And I think I will do that in the next episode, just to show the point of it, or how you can use properties in a nice way or somewhat nice way to limit your values, for instance, or anything like that. You may, for instance, have a game or a place where your value should never exceed 100, but it should never be below 0, for instance. And therefore you want a property to handle that. Every time the value is changed, you want to handle it somehow. I will do that in the next episode. For now, I think it's time to cut it, so thank you very much for watching. Question in the comment section, and as always, take it easy.